So good morning, guys. My second question is coming from TikTok. Remember, I said I'll answer 20 questions as my way of giving back to the society. So my second question is coming from Ninja Food Vlog. Ninja Food Vlog says, please explain the difference between quantum mechanics and classical mechanics. I always get this question. So let's start. First things first, classical mechanics deals with studying particles and properties in the macroscopic form, the bigger form of it. While quantum mechanics deals with studying particles, properties in their microscopic form, their smallest parts, the parts that your eyes cannot even see. That's where you study them. Let's go. Let me teach you something. Okay, so we are going to the difference between classical mechanics and quantum mechanics. So one of it, this is classical mechanic, then this is quantum mechanics. Right? The classical deals with macroscopic, while the quantum deals with microscopic. This, the large parts, particles that you can see with your eyes, quantities that you can measure, small parts. Now you can see the large ones. Now microscopic, small grains, the ones that we can study with microscopes. This one, the ones that are large, and then they are different. I'm using a table so that we can understand it. They are different. This one, there are two ways to measure in classical mechanics. First way, classical mechanics number one is deterministic. Number two, it's continuous. Why in quantum mechanics, there are two things. First of all, it's probabilistic. The second one, it is quantized. Quantized. Now let's break it down. What do they mean by deterministic and probabilistic, continuous and quantized? Deterministic means if you're given a property, when you give me property to solve, you tell me, for example, you give me 15 naira. My return on investment is supposed to be 100 naira. I know that when I invest in that business, I will get 100 naira. So 15 naira will give me 100 naira. Anywhere in the world, $50 will give me $100. Anywhere in the world, no argument. But for probabilistic in quantum mechanics, because you are dealing with small particles and the changes that occurred, like when I explained the principles of double slits in my first question when I was asking my colleague, that's what happened. The result was probabilistic. When I told you that light from a source comes, strike two parallel slits, and their results, like from this source, they strike two parallel slits that can allow light to passing through. Then this is the mirror, Then the result is one dark and one this. Then when you bring a detector, you see only one light there. This is probabilistic. In fact, they don't even know what happened in the principle of double slit. This is probabilistic, and that's what leads us to the wave-particle duality. The difference is that here, instead of taking a grain of rice that you can see, you take a grain of rice, pieces it to powder, then take one small part of that powder and study it. They will have, here is telling you, they will have different properties. You can assume. But here, once you are given a quantity, you expect the result anywhere in the world, any quantity that has the same property of matter as that quantity being investigated. So that's what the difference between deterministic and probabilistic. Now, continuous and quantized. When you talk about continuous, it means anywhere in the world, this is what keeps happening, a reoccurring thing. Like when somebody has gone to the police station over and over, and you sit in your house and say, don't worry, this person, you will see him in the police station again. Continuous. We know that water boils with 100 degrees Celsius anywhere in the world. Yes, so even if we are in Nigeria and somebody is in the US, Water will boil with 100 degrees Celsius. That is what we call continuous. But quantized, different particle behavior. I might take a particle of a substance or a small particle of water. Maybe it has been altered, we don't know. Because there are different things that comes up. There are different ways in which such things can be altered. Now, instead of giving us a particular, because we're taking a particle, there's a property and a change and a method that property is given. Here, we can still use wave particle duality here.